In this video, we're going to talk about a geometric series. A geometric series is a sum of terms of a geometric sequence. There are two types of geometric series, an infinite and a finite type. And the first one we're going to talk about is the finite type. The sum formula for this finite geometric series is S sub n equals a1 times 1 minus r to the n over 1 minus r. So in our first example, we have to find the sum of this finite geometric series. So to do that, I need to figure out what I need first. I need a1, which we know is 3. I need to figure out the ratio, which I can find by dividing my terms. So 12 divided by 6 is 2, 6 divided by 3 is 2. So my ratio is 2. Now I need to know the number of terms. So I know what the last term number is, but I don't know how many total terms there are. So this, remember, last term is also a sub n. So I need to refer back to my geometric sequence formula to figure out what n is. That geometric sequence formula, remember, is a sub n equals a sub 1 times r to the n minus 1. So I'm going to plug in those values that I know, and then I can solve for n. And then I can use that n to plug into my sum formula over here that I need. Alright, so I have 30, 72 equals my first term, which is 3, times my ratio is 2 to the n minus 1. First thing you have to do is divide by 3, so that gives me 1024 equals 2 to the n minus 1. So now you have to think back to what we learned a couple of units ago. Okay, this is to a power of n minus 1. So how do you get rid of this exponent? You're going to use the log of both sides. I'm going to take the log of 1024. There we go. Take the log of 1024, log 2, which brings that n minus 1 down. So that multiplies onto the log of 2. And then I can divide the log of 2 over. So I have log 1024 divided by log 2 equals n minus 1. And if you punch that in and solve, you get n equals 11. So I know there are 11 terms in this series. And now I can plug that value in to get my sum. So S sub 11 equals my first term 3 times 1 minus my ratio 2 to the 11th over 1 minus 2. Now when you punch this into your calculator, this 2 to the 11th is by itself. It's not negative 2 to the 11th. It's 2 to the 11th, and then you subtract all of that from 1. So make sure you use extra parentheses where you need them, or punch it in one by one. Do 2 to the 11th, and then do 1 minus that, and then multiply that by 3, and then divide. So if you do all that correctly, then you should get a sum of 6141. All right, next one. So on B here, we have this in summation notation. We have our lower limit, which is 0, and our upper limit, which is 20. If I look at my sum formula, I know I need a sub 1, so I need my first term. If you remember, for our summation notation, you're going to plug in the lower limit to get your first term. So that means a sub 1 is going to be 4 times a half to the 0 power. That's just going to give me 4. Then I need my ratio, which in this case is a half. And then I need n, which is my total number of terms, which again is upper minus lower plus 1, which means I actually have 21 terms, not 20 terms, because I am including that 0 for that n value there. Alright, so if I plug this in, I get S sub 21 equals a1, which is 4, times 1 minus a half to the n, which is 21, over 1 minus a half. Again, make sure you are careful with this 1/2 ratio. It's 1/2 to the 21, and then 1 minus all of that. So if you type that in correctly, then you should get a total of 8. Seems really small because you're adding 21 numbers together, but remember your ratio is a half. So it starts with 4 and then it gets cut in half. So it jumps to 2 and then 1 and then 1/2 and 1/4 and then smaller and smaller and smaller. So that's only going to add up to 8. In this last example, we need to find a sub n given s sub 4 equals 26 over 27 and r equals a third. So that s sub 4 is the sum of 4 numbers. So I'm going to use my sum formula to figure out the missing parts that I need. So 26 over 27 equals a sub 1, which I don't have, times 1 minus my r, which is a third. I know it's to the fourth because this was the sum of 4 numbers, over 1 minus a third. Now I'm going to simplify. And then I can multiply that 2/3 over, which gives me 52 over 81. And then a1 equals 13 over 20. Alright, so I have a1, but the problem is the question asks for a sub n. So do I have a formula that tells me what a sub n is? Yes. It's a geometric sequence formula, which is a sub n equals a sub 1 times r to the n minus 1. And I have all the parts that I need, so I'm just going to plug in that info. And there we go. Now I have a formula that will find any a sub n term that I want. Alright, lastly we have infinite geometric series. We have two types, one that diverges and one that converges. A divergent one is when the absolute value of r is greater than or equal to 1, and that has no limit. We can't find what it's going to approach because it's divergent. When it's convergent is when the absolute value of r is less than 1. Then we have a limit or a sum, and we can find that by taking a sub 1 over 1 minus r. Alright, so in these examples, we have to determine if the series diverges or converges, and if it converges, we'll find the sum. So in this first example here, we need to find our ratio to determine if it diverges or converges. So it looks like it's 2 here, but let's double check, just in case. So I'm double checking by plugging in, starting with the lower limit, so that 1 minus 1, and then I'll plug in 2 to get 2 minus 1, which gives me this, and then this. So if I find the ratio here, I get 2. So r is 2. Well, if we look at our definition, the absolute value of r is greater than or equal to 1. Yes, it is, which means this is divergent, so it does not have a sum. Okay, so why did I want to double check? Well, what if I gave you a problem that looked like this? Okay, and then you plugged in 3. Now you have a negative exponent, which means that 1/2 is going to flip over, have a ratio of 2. So it may look like it's convergent because this is less than 1, but once you double check by plugging in some numbers, you'll see that's not the case. So that's why I always double check. Alright, b. Let's find the ratio. I'll start with 1/3 divided by 1. This is negative 1/3. Take the 1/9 divided by negative 1/3. It's negative 1/3, which means ratio is negative 1/3. Remember, I need to take the absolute value of that, which would just be 1/3, which is less than 1. So this does converge, which means I can find the sum. So s equals my first term, which is 1, over 1 minus negative 1/3. turns into a plus. So you get a sum of 3/4. Notice what's different about this from the finite arithmetic or finite geometric is that there is no subscript right here. Nothing down there because this is infinite. It goes on forever. And you might say, oh, why don't we put infinity there? I don't know. You just don't. All right, let's look at C. So again, to figure out my ratio, I'm going to plug in just to be safe. Get 1.6, 0.32, 0.064, which gives me a ratio of 0.2, just as I suspected. But notice my first term is 1.6. You might ask, okay, well, why isn't the first term 8? Well, if you look at my exponent here, my exponent isn't n minus 1, it's just n. So when I plug in a 1, what it is evaluating is my first term, not the n minus 1. When you have n minus 1 and you plug in a 1, you get a 0, which gets rid of the ratio part. So, example, if you had this, you plug in the 1, you get 1 minus 1, which is 0, which means this is just a 1, so you just get 8. But because this example doesn't have that n minus 1, then when I plug it in, I get a different a sub 1 than I thought I would. Alright, so now that you have that info, you can plug it into your formula. 1.6 over 1 minus 0.2. And again, I can use this formula because it is convergent, because the absolute value of the ratio is less than 1. You get a sum of 2. Alright, last one. To get my ratio, I take 1 divided by a third, 3 divided by 1. I'm going to get 3 for everything. So R is 3. So this is divergent. And that's everything for geometric series. Let me know if you have any questions.